We have almost full house in the purple stage as yesterday. And our next speaker is a programmer, an artist, a musician, and a pokerist. His career's mission is to make geeks feel safe in the world. Today, with the talk Canon Test-Driven Development, let's please give a very warm welcome to Kent Beck.
Good morning. Is it morning? Okay. My soul is somewhere over the Atlantic anyway, so very good to meet you all briefly. Let me get that off because it's too soon. There we go. Today I'm going to talk about yesterday, keynote, big ideas. Today I'm going to talk about a small, specific, geeky idea. I have been programming my brains out for the last month. I am having so much fun with my programming genie. You know, genie, it grants your wishes, but not the way you think it should. So I'm programming with the genies. I'm reapplying test-driven development. I'm having such a good time. And seemed like a good time to reiterate what I meant by test-driven development. Now, the kids, we didn't have this adjective when I was younger. The kids use this word canon to mean the original. So canon Lord of the Rings is Lord of the Rings as Tolkien wrote it, not as all the fanfic, all the crossovers from Buzz Lightyear, Aragorn, Get Together, none of that stuff. The original, canon means the original. And why am I talking about this? That's a question I've asked myself a lot. Why do I still have to talk about this? And it's because I hear critiques of test-driven development all the time that aren't critiques of test-driven development. So I thought, all right. And I've had a series of essays on my newsletter about this, like what is TDD? So I decided, okay, I'm going to go back to first principles and say, what is test-driven development? My goal today is not to tell you how to program, not at all. And that's not the goal with test-driven development in any case. My goal is to present a clear target for criticism. So people will say, oh, I don't like TDD because I don't want to go write a whole bunch of tests before I write any code. I think, no, that's not it. And other people will say, oh, I don't like TDD because I write a bunch of code and then I have to write a bunch of tests. And I think, no, that's not it. That's not the workflow. The workflow, I thought it was perfectly clear, but apparently not. So I'm going to say it one more time. And that's the threat, that this is just going to be one more time. We'll see how that goes. So this is Canon TDD. This is not how you should program. This is a thing. If you want to criticize a thing, criticize this thing. And then we can talk about variations from there. Okay? If you have questions, I want to respect our sponsor, Slido, without whom my soul would still be in California, and I wouldn't have been able to fly here. But also, if you have a question, please interrupt me now. I would rather entertain your question right in the moment than have you sit there and stew on it for 40 minutes while you don't listen. So feel free to stop me. I'll take questions at any time. I'll repeat the question, and we can go ahead. If it's not a immediate question, get on Slido and get those questions in there. So how many people are using TDD on a regular basis now? Okay. So if you could beat up the other people, then we'd just be finished. No, please don't do that again. All right. So, and in classic Kent style, I'm gonna handwrite all of my slides. Oh, what color? My goodness. All right. So we're going to derive a new programming workflow from scratch. We're going to just pretend we don't know anything about programming. We're going to think from first principles. What sequence of decisions should we take in what order? So the first thing to think about is, what is it that we want to end up with? At the end of this process, we want to end up with a bunch of code, because that's what implements the features. But because we want to continue changing this code, we also want to end up with a bunch of tests. Now, the goal of the tests are twofold. One is confidence that the code actually does what we think the code does. That's confidence for us personally, confidence for our colleagues. Oh, I changed some code. Oh, no, again. Please don't do that. No, if I have tests, you can have more confidence in what I do. And confidence for our users. I got into a BMW the other day, and it said over-the-air upload available. And the owner of the car went, cancel. I just don't want any upgrades. That's sad. That's a commentary on our profession, that people don't trust us not to break things. So at a large level, we'd like to have confidence, and we'd like to share that confidence with other people. So this is where we want to end up. So how do we get there? So one sequence that we could use is we could write some code, and we could write some more code, and we could write some more code, and then we can write a test, and another test, and another test. This is a very reasonable sequence. People will say to me, okay, but TDD doesn't fit my workflow. My workflow is I write the API docs, then I figure out what the modules are going to be. It's kind of sad that we still put source code in files, but that's a topic for another day. So I write the API docs, I figure out what the modules are going to be, I figure out which functions go in which modules, then I fill out the body of each function, and then I'm finished. I think, well, it doesn't sound like a horrible workflow, but what happens if you make a mistake here or discover something that affects the first part of the code? Oops, now I have to go change two things. And then if I find a mistake here that causes me to have to change something in the previous code that I wrote, that causes me to have to change something in the previous code that I wrote, because coupling. Okay, so that's potentially an expensive scenario. So what if we got some feedback before we got here? What if we wanted feedback before we got there? Okay, so here's another sequence we could follow. I could write some code, and then I could write a test. And now I have feedback about whether that first code works or not. And then I could write some more code, and then I can write a test, and I run both sets of tests, and I make sure everything works, and then I write some more code, and then I write another test. Okay, so this prevents or reduces the chance of this kind of scenario where I learn something later that invalidates my work earlier. But this introduces a dependency between, which color? I'll go with this one. What this sequence means that when I write this code, I have to write something that'll run already. So my friend's sequence, where they write the API docs, and then they lay out all the files, and then they lay out all the functions, you can't run that. You can't compile it. You can't run it until you've finished everything in that. So there's a skill here where I have to decompose all this code that I'm going to write. I have to break this down into chunks that are maybe different than the chunks that I would use if I was in this kind of workflow. I have to write code here that's capable of being compiled and run. Now, depends on your programming language and your programming environment, how easy or hard that is. But that is an implication of splitting up the testing and doing it a little bit at a time. Then I have to figure out how to write tests just for that part. Then I write the second segment of code, which also has to be able to run so that I can run the tests for that. Then I have to write the third part of the code so that I can test them all together. So there's a skill to this sequence, this bottom sequence. There's a skill to it that's not necessary up here. Here, I can write the lines of the code. Let's say I'm going to end up with 1,000 lines of code. I can write them in any order I want. I can start at the beginning. I can start at the end. I can start someplace in the middle. I don't have to worry about the sequence in which I write those lines of code. If I'm going to follow this sequence down here, interspersed code and test, then I have to learn the skill of sequencing the lines that I write in such a way that I can run them before I've written them all. Here, I have to write them all, then I can run them. Here, I have to figure out how do I slice the salami up and what order do I eat the slices so that I can run it before it's finished. And there's definitely a skill there. I don't think anybody's really dug into that skill. Like, what are the common patterns? What's the pedagogy? How do you teach that to somebody to do? Nobody's ever. So if you're looking for a project, like really digging into what does that mean that I write the lines of the code in a specific order. You know, if I have 1,000 lines, I have 1,000 factorial permutations of those lines. Some of those permutations make sense, and others of those permutations don't make sense if I want to achieve this goal of being able to test piecemeal like this. Any questions so far? Good, I think. So, another implication.
Kent.
Yes.
We have a question. On the note about the source code. Sorry. On the note about source code. On the note about the source code into file. What are the reasonable alternatives?
What are the reasonable
alternatives? On the note about the source code into file, what are the reasonable alternatives?
Oh, if you don't put source code in files, you put it in objects. It's been done for 40 years. It works really nice, but nobody wants to hear that answer. So, small talk.
Thank you.
But we have that conversation afterwards. Okay. So, now we come to a question. So we have this code and then test sequence. The code part of this here further breaks down into 3 distinct sets of questions. So I have some feature that I want to add. I want to change the behavior of the system. I have to make 3 sets of decisions. I have to decide what's the API, how do I invoke this feature, what is the input-output behavior, that is, what inputs go into the logic I'm about to write, and what outputs do I expect from that logic, and the implementation itself. I have to think of all 3 of those things while I'm doing the coding, I have to finish all three of those before I can move on to the test. So I think, all right, here's the smallest unit of implementation. I'm going to make this little change to the system. I have to decide how I will invoke it, what I expect the inputs and outputs to be, the domain and range, and how the implementation is going to be structured. And I have to make all three of those decisions so that I can write the test. Now, one of my fundamental principles is breaking down complexity. So I want to subdivide complexity. So I have a big complex problem. I would divide it into two or more simpler problems that don't interact. People forget the that don't interact part, but that's pretty important because otherwise you have to solve this problem and that problem and their interaction, which is harder than just solving it in one big chunk. So when I have this sequence, code and then test, which makes perfect sense, I have to make all three of those decisions before I can get feedback on what I've done. Now, back in late 80s, maybe, when I wrote the first testing framework, the JUnit is the Java one that lots of people have used. I wrote a testing framework in Smalltalk before that. I had written that. I was writing a lot of tests along with my code. And I had this goofy idea. It's a stupid idea, right? And by the way, try the stupid ideas. Because if they happen to be right, they're going to be really valuable, number one. And number two, you're not going to have any competition because nobody else is stupid enough to try the stupid ideas. This principle is particularly important when things are changing fast, like they are in our profession right now. So if you're thinking, should I try the coding genie? Absolutely. And do every crazy experiment you can think of, because if it works, it's going to be extremely powerful. Okay, so I had this testing framework which made testing cheaper, simpler. I could write a bunch of tests. I could run them all together. That was really fast. And I thought of this idea of what if I swapped them? Everybody codes and then tests. That's what makes sense. But what if I swapped them? And I remember laughing out loud when I had that thought. That was one of those stupid ideas. It makes no sense. If I write the test first, it's going to fail. And I want the test to pass, right? So why would I write the test when it's guaranteed to fail? If I write the code and then I write the test, maybe the test passes, maybe it doesn't. But if it passes, woo, I win. And if it fails, then I'm sad. So I'm going to swap that so that I write the test first. It's guaranteed to fail. I'm going to have to cry every time. All right, well, let's try it. So my first example was just stack. Create a stack, it's empty, push and pop. I pop the same thing I pushed. Push two things, pop two things. They come back in the right order. I try and pop an empty stack. Am I done? Yeah. Like, I can't imagine another test I could write that would fail. And that moment for me was just magical because I'm an anxious person. And this is like Xanax for programmers. It absolutely calms the anxiety. It's like what else could break? I wake up in the middle of the night and I think, I'll just push the button, run the test, so I can go back to sleep. Now, I'm not saying I do that. I'm not saying I don't do that either. So, okay, so here's one of the cool things about this is if I write the test first, I get to choose what order I make these three sets of decisions. and I get feedback at every step. So if I write the test, to write the test, I have to decide. I don't actually have to. I'm going to get that to in a second. I have to decide what's the API. Oh, I have this stack object. It has operations push and pop. Okay, and that's what's represented in the test, but I don't care how it's implemented. Is this implemented as a linked list or an array or some probabilistic structure or whatever? I don't know. I don't care. Then I can decide on the input-output behavior. Okay, in this case, I push one, I pop one, I get the same thing back. That's the input-output behavior. And then I can go and try the implementation. Okay, we'll make this a linked list, blah, 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 and away we go. Or it's a stack, or an array, and away we go. But I don't have to do it in that order. I can start with the input-output decisions. This is a technique, assert first, that James Newkirk taught me, where you start with the last line of the test, and you say assert equals actual expected. Okay, well, what's expected? I expect to get a 5 if I pushed a 5. So the expected is a 5. What's the actual? Actual equals the temporary variable, stack, pop. Okay, but before that can happen, I have to say stack.push 5. And before that can happen, I have to say stack equals stack new. So I can make this decisions that add up to the same thing, but I can make them in a completely different order if I'm working inside the test. So I start with the input-output behavior. I go to the API in that case. Now I have to go make the implementation. Now, you look like a pretty advanced audience, so I'm gonna dig into a cool. Yeah, I'm a little bit blowing sunshine up your butts, but that's okay. You actually do look like a pretty experienced audience. You can actually make these decisions in a different order. We can start with the implementation. This is a technique Keith Braithwaite, my friend, calls TDD, as if you meant it. So I'm going to implement in my test, I'm going to implement the logic of push and pop that I expect to use later somewhere else. So here's the algorithm. I create an array. I have a pointer to the head. Push is, let me add something to the array and advance the pointer. Pop is, let me take something away and decrement the pointer. Now I can say expected equals actual, and away I go. So I can do the implementation. Let's say I don't know how I want to invoke it. I don't know if this is a function someplace. Maybe it's an object someplace. Maybe it's its own module. I don't want to make those decisions yet. I can still work on the implementation, and then I can figure out the input-output behavior, and then afterwards, I can extract this implementation that I have living temporarily in a test into its final resting place somewhere else. By switching the code and the test, I've freed up my workflow to be able to make decisions in any order that I want. So that's kind of cool. Yes? Question.
In terms of doing implementation first, if you say I'm going to use an array, you're already making the implicit assumption of the size of the array.
If you're using an array, you're making the implicit assumption of the size of the array. Yes, yeah, absolutely.
Which means that eventually later tests will blow up if you do too many.
You're certainly at risk of overflow, so you better write a test for that later. Don't not write a test for that later, which is another argument. Oh, if I use TDD, I'm just going to satisfy my current tests, and then my code won't really work in the general case. Well, don't do that. Yeah, I don't understand the intensity of the emotional reactions. If somebody could explain that to me, I'd sure appreciate it. I get people coming up to me deeply ashamed. Well, I don't do TDD. Does anything about my face make it seem like I care? And then I get the angry, you can't make me do this. Does anything about this face make it seem like I care? But anyway, somebody can explain that, and it's not going to be me. All right. So, one more thing. Before we are going to get to Canon TDD, I promise. But before that, I want to think for a second. We have this alternative. We can do our workflow, code and then test, or we can test and then code. What are the economics of that? Why is it that we want to do testing interspersed with, right? We had this, we can go code, test, or code, test, code, test. What are the economics of this? Why do we want to take the extra burden of constraining the order in which we write our code? So here's me thinking about that a little bit. Here we have value and cost over time. And right here is, I should probably write this out. Here is the code. So if we write tests way before we write the code, they're of little value because we're making a whole bunch of assumptions. We're going to have to go rewrite the tests. We have to maintain them even though everything might change. We might not even implement this. So there's more work that we abandon. The closer we get to implementation time, stupid drawing program, that's not a straight line. The closer we get to implementation time, the more valuable the tests are. Because they tell us we made these API, input-output, and implementation decisions. They give us feedback about whether those are correct. So right about the time we write the code, the tests peak in value, but then the longer we wait for feedback, the less valuable the tests are. So after we ship the code to production, the tests just aren't very valuable at all. The costs have a similar curve, except this is negative. If we write the tests way early, the cost is very high because we're going to have all this rework. And the closer we get, the lower the cost gets, so that right around the time we write the code, the cost is the minimum. If we don't write tests right around the time we write the code, though, the code will not be testable by default. You can have habits that help your code be testable, but it'll be more and more expensive as time goes on. So if we sum up these two curves, this one minus this one, clearly right around the time we write the code is the most valuable and least expensive time to write the tests. And that's why we pick this sequence, this code and test, except then we have the question of what order do we do them? What order do we start the sequence? Okay, so now we're ready for Canon TDD. That's why we're making all of these decisions. It's a two-step process. Step one, scenarios. That is, we're implementing some feature and we think, okay, well, we have to handle overflow, underflow, one element, two elements. Anything else? No, we can't think of anything else right at the moment. Well, types is going to be part of the test. Sorry?
Array of int and then
Oh, well, that's going to be part of the test that we write. The scenarios are, what are the paths through the logic? So maybe we have two different ways of calculating interest rates. We know that we're going to have at least one test for each way of calculating interest rates. So I always start with a list. And maybe this is back to me and anxiety and ADD. I don't like the term attention deficit disorder, by the way, because I don't have a deficit of attention. I have a lot of attention. I just get bored really easily. So I prefer to call it boredom sensitivity, which is like a peanut allergy, except to boredom. So I need a way to focus my attention, of which I have so much, but it's very variable. And TDD helps me do that, and the scenarios help me do that too. The second thing the scenarios help me is, how will I know I'm done? Because I'm that anxious person. I could always think of one more thing. If I have a list of scenarios and I've crossed them all off, I mean, in my whole life, I have many, many lists with things crossed off. And that's a way of managing my own anxiety. So I start with a list of scenarios. Here are the paths through the logic that I know about today. Then step 2A is write a test. That is, I'm going to write some sequence of statements that will be green if I have made progress on my project, and it'll be red if I haven't made progress on my project, whether I think I've made progress or not. So that's the test-driven part of it. 2B is make it pass. That is, once I have a red test, I really don't care about anything but making it green. How can I get it to green as quickly as possible? And here's where I'm using my anxiety to my benefit. Like, I could imagine a million other scenarios and how am I going to implement this and how am I going to implement that. And I can spiral off into my favorite displacement activity is polishing my nails because I'm a classical guitarist. So if I get really worried about the coding that I'm doing, I suddenly go, oh, no. And then I walk to the bathroom and I file my nails very carefully for a while, which that doesn't actually get any code done. I don't know if you noticed that, but that's just my displacement activity. So I have a test, it's red, I'm going to get it to green. Now, I'd like to get it to green with the code that I expect to write, but maybe I don't have to. That is the fact, this is a great conference, and it's a great venue, and the fact that they scheduled a train right in the middle of my presentation is just so hospitable. I really appreciate that. So, I want to write the code that I want to write, but maybe that's too complicated for me to do. So, I'll commit all kinds of sins in the make it pass part if I have to get to green, because I know I'm always going to come to C, which is the generalized step, where I take test-driven development is driven from specific scenarios, but we want code that operates in general circumstances. We want to pick tests or a set of tests that's going to imply that all the other inputs are also going to work. So, in this generalized step, now I'm back to green. I have a new test. It passes. I want to keep it green while I generalize. And I can do this in a number of different ways. Again, here's a great research topic if you're like a master's student. What are all the ways that you can generalize your code once you have a test passing? So, for example, I can generalize the design. I can say, okay, well, I got the test to pass, but I had to copy pasta some code. Do you have copy pasta in Hungary? where you copy some code, you paste it in, and then you edit it, and now you have coupling? You don't do that here? No, yeah. I'm believing you, sir. Okay, so maybe I did that, but I see, okay, well, there's some duplication between this code and that code. So let me extract a helper here, and I'll use the helper over there. Now I'm generalizing. That's generalizing the design. Sometimes I generalize the implementation. So this is something I published the other day, I think, on LinkedIn, about this sequence where I have a test that says, I have 100 euros, I collect 5% interest. After a year, I should have 105 euros. And I might, in my implementation step, that make it pass step, I might just say return 105. Except I know I'm not finished. So what that 105 is actually the principal plus the interest. So I replace the implementation that just says return 105 with return principal plus interest. And principal just says return 100, and the interest just says return 5. And then I go back in and I say, oh, but that principal is actually the initial deposit, which was in the test, but now no longer appears anywhere in the implementation. Now I have to find some way to hook that together, and the interest is a rate times the principal. And where's the rate come from? And then now I have perfectly general code, but I made most of the implementation decisions with the tests all green. That's just magic to somebody who's anxious. Sometimes I can simplify. I did something to get the test to pass, and I'd say, oh, well, actually, I can restructure this computation so that it's something much simpler. Okay, good. And sometimes I abstract. I say, all right, well, I got this to work. I had a concrete class, and now I want to introduce an interface for that class because I'm about to use it, or because it will read better to future readers, or whatever. But that generalization step, this is a piece of TDD that many critics seem to miss, is how much time I spend on generalization. I recorded a series of screencasts that you can find on YouTube where I used a variant of TDD called test, commit, revert, where if the test fails, all the changes since the last passing are immediately deleted. This is a terrible idea, and it's so much fun, and you should try it. So I had built this data structure, this rope data structure, and I spend the last half, so it takes about an hour, and I spend the last half hour just on refactoring, just on this generalization step, to make it look more like Python. I think it's implemented in Python, to make it look more like Python, to like just it's tidying that thing up so that it's ready for the next step. And I think that's something that does get missed. So that there, ladies and gentlemen, and everything in between is Canon TDD. Should you follow this set of steps? I was about to say absolutely not. Maybe you should follow this set of steps. If you want to criticize TDD, criticize this. I'm happy to have that conversation. Somebody who says, well, I hate writing a whole bunch of tests before I write any code. I'm not interested in having that conversation because it's not about TDD. So this is the basic. Now, if I was teaching, you said, come give us a workshop on TDD, I would teach this as a starting point. Pragmatic Dave has a wonderful Substack that's just getting started, and he talks about his own personal workflow. And in his personal workflow, there's times he doesn't write tests, or there's times he writes tests afterwards. That's mastery. And getting to that where you don't really consciously decide when you're going to do things. You let your judgment and your intuition drive. That's a powerful place to be. But to get there is going to require playing some scales first. And following this workflow is the scales of programming. It's not the music. This is a place to start. It's certainly a place to critique. If you didn't understand TDD like this, I hope you give it a try. If you try it and it works or doesn't work or you find problems with it, I'd love to hear about it. But this is what I was trying to describe in the original TDD book, what I've been trying to describe for the last 25 years. And so here we are. Yeah? Thank you so much for your time and attention.
Thank you so much, Kent. We have a ton of questions. Sadly, we won't have time for all of them. So I
Let's get
recommend,
going.
or as a suggestion, just keep them very short if you can.
Okay.
Okay? All right. In the stack example, how many tests would you write up front?
1.
All right. How does TDD work with tests?
Is anybody surprised by that answer? Okay.
All right. How does TDD work with testing at different abstraction levels, unit, integration, E2E?
I don't care. I bounce between scales all the time. And there is certainly a skill to decomposition, to saying, okay, I got this big problem. If I solve this part of the problem and that part of the problem, the composition of the two will solve the full problem. There's a skill to that decomposition. You can make mistakes about that decomposition, which is why my preference is to solve whole problems first and then subdivide, grow like a tree grows. But we can apply the same set of principles. If you'll notice, I applied the principle to the talk itself because I'm a computer scientist and I just can't help it. I said, where do we want to end up? We want a bunch of code and a bunch of tests, and we want to feel confident. That's where we want to end up. Okay, how are we going to get there? That's that same kind of thinking.
Thank you. How can I trust more in my test than my code?
You can't. Accountants call it cross-footing. If I have a matrix of numbers and I add them up row-wise and then down the column, and column-wise and then across the row, and I get to the same answer, I can still have made exactly offsetting errors in my arithmetic, but the probability is much smaller. I don't trust my tests. I don't trust my code. That's why I want to arrive at the same answer from two different paths. That's why it is a sin against TDD to write some code, print out the actual result, and paste it into a test. You haven't double-checked anything. All you've done is make sure that answer doesn't change. But that's completely different than, I don't know, let's have the actuary calculate the number, and then we'll calculate the number with our code, and then if they match, we're much more confident. Probably, if I have a test that's failing and it's a surprise that it's failing, probably a third of the time there's something wrong with the test, and 2/3 of the time there's something wrong with the code. That's my personal observation. Again, what an awesome master's thesis project to go and instrument TDD somehow, somewhere, and figure out what percentage of the time tests are broken versus what percentage of the time code is broken, and can we come up with a taxonomy of the failures in the tests? That would be an awesome project. I'm not going to do it.
Thank you. Is TDD still relevant when AI can generate proper unit tests from specification?
AI cannot generate proper unit tests from the specification today. I have evidence of that from yesterday. It might be different tomorrow. Is TDD still relevant? I think the genie is the rebirth of TDD. Anytime you have a non-deterministic system that's sensitive to initial conditions in the complexity theory sense, the way you get some control over that system is always inhibition. You have to stop something from happening. And the tests I have found are a great way of stopping the genie from doing stupid shit. Except when the genie figures out that all it has to do is delete the tests, or comment out the tests, or just comment out the assertions, and then they pass. So me and the genie have to have a little talk about that every once in a while. But using tests as a way of saying, abounding the set of solutions, the genie's going to go off and give you all different kinds of solutions. The tests that you as a programmer specify are a way of saying, no, only these things are good code. You go make the code you want, but it has to satisfy these requirements.
Thank you. Last question. What if I write a lot of tests first? Because I know many... We have time for one more question.
It is so simple. Don't do that. If you know the scenarios, then you don't have to write a bunch of tests. I can write T1, T2, T3, T4, and I can have code in between, and it's not going to cost me anything. So why would you do it up front? Why not wait? Because if I wait and I discover something new, I'm always going to bet on me being ignorant and learning something. And by deferring the actual writing of the test, that gives me a bigger chance to learn and less friction as I make progress.
Okay, that was quick, so let's go for one more.
Okay.
Do you think techniques like property-based testing pair well with TDD? Or does it make the generalization step while the tests are green too painful, as you might need an actual implementation for most of the tests to pass?
Here's my challenge with property-based testing. And I've written property testers. I've used them. The problem with for me, is the complexity partitioning, this idea of how can I make this complexity here and that complexity there. And being able to handle that kind of one chunk at a time instead of having to swallow everything at once. If I write a property-based test up front, I have to finish the implementation before I get the dopamine hit from passing tests. I don't mind property-based tests. So I was working on a library kind of data structure, B+ tree, and I ended with property tests, but I didn't start there. I started with specific, if I insert one item, then 2 items, 4 items, 5 items, now it's different, et cetera, et cetera. So I think property-based tests have a place, but in the workflow of discovery, I think they make it harder for me to make partial concrete progress. And that's me. Other people might think something completely different.
Thank you so much, Kent. Let's give him a round of applause.
Thank you.
Thank you so much. This is a little
super
present for you.
Thank you
so
very
much
much
for being with us.